Let's jump right in with an example. So we have a 3 by 3 matrix A. We have a vector -4, 2, 4. We are told that this vector is an eigenvector of matrix A. We need to find the corresponding eigenvalue to that eigenvector. All right. So first, let's remind ourselves what an eigenvector means, what it means that this vector is an eigenvector. So let me give this vector a name. Let me call vector -4, 2, 4. Let me call it vector x. Now, because x is an eigenvector, that means if I take matrix A and multiply by vector x, that has the same effect as scaling vector x by some scalar value lambda. Okay, our task is to find lambda. So let's plug in the matrices and the vectors we do know about. So we know what matrix A is. Matrix A is -11, -8, -4, 5, 3, 2, 11, 10, 3. So if I multiply that by my eigenvector, vector x, -4, 2, 4, I should get some scalar multiple lambda times the same eigenvector, -4, 2, 4. So my job is to find lambda. So let's just do the vector multiplication, the matrix vector multiplication on the left side. Let's do the scalar vector multiplication on the right. And then we can equate the two sides together so that we could find the scalar value lambda. Okay. So on the left side, for the first term, I'm going to take the dot product of the first column of the first row of the first matrix and the first column of the second. So I'd get 44 plus -16 plus -16. So 44 plus -16 plus -16, that's 44 minus 32, which is 12. Okay. Next row. So second row, dot product with the first column. So that'd be -20 plus 6 plus 8. 8 and 6 is 14. -20 minus or plus 14 is -6. And finally, last row, first column, I get -44 plus 20 plus 12. -44 plus 20 plus 12. 20 and 12 is 32. So -44 plus 32 is -12. Okay. And then on the right side, multiply in that scalar multiple of lambda. I get -4 lambda. I get 2 lambda. I get 4 lambda. Now, assuming that the system here is consistent, we actually only need one row to find lambda, don't we? So looking at the first row, I get 12 on one side, -4 lambda on the other side, and we can see real quick lambda must be equal to -3 in order to make this work. Okay? Do make sure generally, we are told in this problem that this is an eigenvector, so this better work. But generally, if you just take any old random vector, you will generally be able to find a value of lambda to make that first row work. Okay? What you need is to also make sure that all the other rows work too. In this case, we could make sure that that's true. If lambda equals -3, 2 times -3 is -6, 4 times -3 is -12. Every entry works. This is the eigenvalue of matrix A associated with eigenvector x.